Parameters and statistics. Suppose we toss a fair coin, meaning there are 50-50 chance of getting a head or a tail. If we toss a fair coin, then we would expect that the proportion of head showed up is 50-50 or 0.5 or 1/2. This means half of the time we will get heads and half of the time we will get tail. That is in theory. But suppose we actually toss the coin 50 times. We do not expect to get 25 heads and 25 tails. Suppose that we toss it 50 times and 30 of the times we will get head, and therefore 20 of the time we get tail, because there's a total of 50. And so the proportion of head in this case is 30 out of 50, or simply put 3/5 or 0.6. It is a little bit higher. And the same thing, suppose we tossed the coin another 50 times. We do not expect to get 30 head and 20 tail. We do not expect to get 25 head or 25 tails. This is due to sampling variability. Now, in theory, the third proportion is what we call the population proportion. So we denote is using p, just simply lowercase p. But for the 50 times, this is 50 times in the sample, and so we will denote it using p hat. P hat is used for the proportion sample, and p refers to the proportion of the population. Let's take a look at another example. Suppose we thought a tetrahedral die which has 4 faces, number 1, 2, 3, 4. Now 1, 2, 3, 4 is a population already because there are only 4 faces in this die. If we compute the mean is 2.5. 1 plus 2 plus 3 plus 4 divided by 4. 10 divided by 4 is 2.5. And the standard deviation is 1.118. Now, to denote the mean and the standard deviation of the population, we use the Greek letter mu for the mean and sigma for the standard deviation of the population. Suppose now we get a sample from these 4 numbers and we want to get the sample of size 3 only. Suppose we get 1, 1, 4. Repetition allowed here, meaning this is done with a replacement. We took 1 and then we put 1 back. Then the second time, it so happened that we pick 1 again. And then the third time, we pick a number 4. And so this is the samples of size 4, and we compute the mean. The mean in this case for the sample 114 is 2. And if we were to compute the standard deviation of this sample, we get 1.73. To denote the mean for the sample, we use the symbol x bar, and to denote the standard deviation for the sample, we use the lowercase s. X bar, s, p hat are called the statistics. P, mu, sigma are called the parameters. Also, with the sample size of the sample is denoted using the lowercase n. In this case, n equals 3. The sample size for the population is denoted using uppercase N. And so in this case, n is 4. And so to summarize this, there are 2 quantities that we just discussed here. One is the parameters. The parameters are the characteristics of the population. It tells us something about the population. What that means is that from now on, if we use the notation lowercase p, mu, sigma, uppercase N, then these tell us something about the population, and they are called parameters. The p hat, x bars notation, lowercase s and n are what we call the statistics. The statistics are the characteristics of the sample. And so from now on, if we use these notation p hat, x bar, lowercase s, lowercase n, then these tell us something about the sample. That is the convention that we will adopt throughout this course.